All right, so we are going to be looking at taking derivatives and integrals of exponential functions. So I want to go through a couple examples, and then if you have any questions after that, we can meet up and talk. So, all right. So the first thing we want to remember is our algebra review. So just knowing these three rules is going to help you tremendously. Looking at our differentiation rule, so if we take the derivative of e to the x, we end up with e to the x. So if we have derivative of e to the u, which means we could have any other exponent, we would get e to the u du. Okay. So that's going to help us out. So looking at our first example, we have y equals e to the tangent of x. So what we're going to want to do here is take derivative. So we have e to the tangent of x. We just write it again. And then we take derivative of the exponent. So derivative of tangent is secant squared. Okay, you can find the derivative of tangent by knowing it's sine over cosine and then doing quotient rule. We should end up with secant squared. Okay? And that would be it. We could write that out front. We could say secant squared x times e to the tangent of x. That would be our final answer. All right, so you're gonna have to know your trig stuff. So this next one, we have e to the negative 4x times sine of 5x. So we have a product rule here. So I'm gonna do derivative of the first one. So we took derivative of this, we would say e to the negative 4x times the derivative of the exponent, which would be negative 4. So that goes there. And then times the second. Plus first times derivative of the second, so derivative of sine is cosine. So we get cosine 5x times derivative of the inside, which would be 5. I'm just going to throw that out front. So that would be your derivative. And we can talk more about these after you try some of the homework problems. All right, so integration. So I have e to the x dx equals e to the x plus c. All right, so we gotta remember that. So we're going backwards, the same thing, and then we're gonna do the same thing with the e to the u. So our example here, we have x squared times e to the x cubed. So what we need to see is that our u is going to be our exponent. So I'm going to take that out, x cubed. If we take the derivative of both sides, we get du equals 3x squared dx. And I see that piece right here, x squared and dx is right here. So I'm going to divide by 3, so we get 1/3 du equals our x squared dx. We can sub in what we know. So we know the x squared dx is just this 1/3 du. So I'm going to take the 1/3 out to the front. Du goes inside. And then this is just our e to the u. So when we take the integral, that's just 1/3 e to the u is just e to the u. So we're going to put this u back in. So we get our x cubed up top and, sorry, plus c. Because we don't have any bounds, so we're going to put our plus c there. So that should be our intro. So if you have any questions, let me know, and we can jump on and talk about it. All right.